Have you ever wondered how pilots navigate through the skies and communicate with air traffic control? If so, you're about to unlock the mysteries of avionics and instrumentation. These are the unsung heroes of modern aviation, ensuring not just the safety but also the efficiency of every flight. From navigation systems to communication gear, from gyroscopes to autopilots, we're going to dive into these fascinating aspects of flight. So buckle up and prepare for takeoff as we embark on this journey to explore the world of avionics. Let's start by understanding what avionics is. Avionics, an amalgamation of aviation and electronics, is the technology used in aircraft for communication, navigation, and display systems. This field is a fascinating world of engineering that plays a crucial role in making air travel safe and efficient. Let's talk about navigation first. It involves systems like the Global Positioning System, or GPS, and inertial navigation systems. These technologies guide aircraft along their flight paths, ensuring they reach their destinations accurately and efficiently. Imagine being a pilot navigating through the vast skies with no landmarks in sight. It's these navigation systems that provide the necessary guidance. Next up, communication. It's not just about pilot-to-pilot or pilot-to-tower communication, it's also about aircraft communicating their positions to each other and to traffic control. This is where systems like VHF radios and transponders come into play. They help avoid collisions and maintain order in the busy airspace. Lastly, let's touch on display systems. Cockpit displays provide pilots with essential flight data, like altitude, speed, and heading. You might have seen images of cockpit interiors filled with multiple screens and dials. These include primary flight displays, or PFDs, and multifunction displays, or MFDs. They present complex data in a simple, easy-to-understand manner, helping pilots make informed decisions. Now let's dive deeper into some specific instruments, starting with gyroscopes and altimeters. Gyroscopes are vital for aircraft stability and navigation, but how do they work? Let's dive in. Gyroscopes are fascinating devices that seem to defy the laws of physics. At the heart of a gyroscope is a spinning wheel, called a rotor, that maintains its orientation no matter how the device is tilted or turned. This principle is known as gyroscopic rigidity, and it's crucial for aircraft navigation. Here's where the magic happens. When a force is applied to the gyroscope, it doesn't react as you might expect. Instead of moving in the direction of the force, it moves at a right angle to it. This is called gyroscopic precession, and it's the principle that makes gyroscopes so useful in aviation. Consider an attitude indicator, one of the most important gyroscopic instruments in an aircraft. It uses a gyroscope to provide the pilot with critical information about the aircraft's orientation relative to the horizon. This helps the pilot maintain control of the aircraft, even in conditions of poor visibility. Similarly, the heading indicator, another gyroscopic instrument, shows the aircraft's direction of flight. It's more reliable than a magnetic compass, which can be affected by various factors such as the aircraft's electrical systems and nearby magnetic fields. But what about altitude? That's where altimeters come in. They are crucial for measuring an aircraft's altitude above sea level. There are different types of altimeters, each with its unique method of measurement. Barometric altimeters, the most common type, work by measuring air pressure. As an aircraft ascends, the air pressure decreases, and the altimeter interprets this as an increase in altitude. On the other hand, radar altimeters use radio waves to determine the exact distance between the aircraft and the ground. They are especially useful for low-level flight and during landing, providing highly accurate altitude readings. In essence, gyroscopes and altimeters are indispensable tools in the world of avionics, playing a significant role in ensuring safe and efficient flights. They provide pilots with vital information about the aircraft's orientation and altitude, helping them navigate through the skies with precision and confidence. Another essential part of avionics is the autopilot. Let's explore it next. Autopilots are not just about letting the aircraft fly itself. They serve a much more complex purpose. Autopilots are the unseen co-pilots, the silent assistants that help pilots navigate the skies with precision and safety. They are essentially computer systems that make use of sensors, servos, and global positioning systems to guide an aircraft. The autopilot system in an aircraft has a range of functionalities. It can control the aircraft's heading, maintain its altitude, and even manage its speed. The autopilot system is like a helping hand that takes some load off the pilots, allowing them to focus on other critical aspects of the flight, like monitoring weather conditions and communicating with air traffic control. But autopilots aren't just a one-size-fits-all system. They come with various modes that can be selected based on the phase of flight or the specific requirements of the journey. There's the heading hold mode, which maintains the aircraft on a specific compass direction. Then there's the altitude hold mode, ensuring the aircraft stays at a preset altitude. And let's not forget the approach mode, which is used during the final phases of flight to align the aircraft with the runway and descend at the correct rate. What's truly fascinating about autopilots is how they integrate with other systems on the aircraft. They work hand in glove with the navigation systems and flight management systems. The navigation systems provide the autopilot with the aircraft's current position and course, while the flight management system feeds the autopilot with the flight plan, including waypoints, altitudes, and speeds. This integration allows the autopilot to follow pre-programmed routes, climb or descend to specific altitudes at preset points, and even adjust the aircraft's speed based on the flight plan. It's like having a virtual pilot who knows the entire flight plan and executes it with precision. Of course, autopilots don't replace the need for human pilots. They are tools that assist pilots, not replace them. Human pilots are still needed for decision-making, especially in unexpected situations or emergencies. So the next time you're on a flight, remember that there's an unseen assistant helping guide your journey, working in harmony with the human pilots to get you to your destination safely and efficiently. Autopilots, then, are an integral part of modern aviation, making our journeys smoother and safer. Now, let's shift our focus to an exciting evolution in avionics, the glass cockpit. Imagine replacing all those analog gauges with digital displays. Welcome to the world of glass cockpits. This revolution in cockpit design emerged from the need to reduce pilot workload and enhance situational awareness. Instead of a sea of dials and switches, pilots now face sleek screens that display a wealth of information at a glance. The term glass cockpit refers to the use of digital or electronic displays in the cockpit of an aircraft. It's a shift from the traditional steam gauge cockpit, where physical dials and analog readouts provide the pilot with information about the flight. The glass cockpit is not just about replacing old gauges with new screens. It's about integrating all the information and presenting it in a way that's easier to understand and use. This is where the real magic of glass cockpits lies. They bring together data from various sensors and systems, process it, and present it in a comprehensible form, offering a complete picture of an aircraft's status. One of the significant advantages of glass cockpits is the enhancement of situational awareness. With traditional cockpits, pilots have to scan a multitude of instruments to gather necessary information. In contrast, glass cockpits consolidate this data into a few displays, allowing pilots to grasp the situation quickly. Another advantage is the reduction in pilot workload. With integrated systems, many tasks that were once manual are now automated, freeing up the pilot's attention for other critical aspects of the flight. There are several examples of aircraft with glass cockpit avionics suites. The Garmin G1000, for instance, is a popular choice in many light aircraft and helicopters. It includes primary flight display, multifunction display, and integrated communication and navigation systems. On the other hand, the Collins Proline Fusion is an advanced avionics suite used in business and regional jets. As we near the end, let's summarize and look at what the future holds for avionics. Avionics and instrumentation are the heartbeat of modern aviation. They guide our flights, keep us connected, and ensure our safety in the skies. We've journeyed together through this intricate world, delving into the marvels of navigation, communication, and display systems. We've seen how gyroscopes and altimeters, these seemingly simple devices, play an indispensable role in our flights, providing stability and precise altitude measurements. We've explored the wonders of autopilot systems, these silent co-pilots that help us maintain our course, altitude, and speed, freeing up pilots to focus on more critical tasks. And we've marveled at the evolution of the cockpit, witnessing the transition from traditional analog gauges to digital glass cockpits, enhancing situational awareness and reducing pilot workload. The future of avionics and instrumentation is bright and boundless. Artificial intelligence integration promises to revolutionize flight automation, making our journeys even safer and more efficient. Enhanced connectivity will keep us more informed and better prepared, whether it's real-time weather updates or critical system diagnostics. These advancements are not just possibilities, they are realities in the making. The world of avionics and instrumentation is ever evolving, driven by our relentless pursuit of innovation and our ceaseless quest for safer, more efficient air travel. Remember, the sky is not the limit, it's just the beginning. Keep exploring and learning about avionics and instrumentation. The journey is as thrilling as the destination.